My dear students, I am taking second part of 10th class, second chapter. Now, the name of the second chapter is Polynomial, and I have discussed first part of this chapter. Now I am taking second part, Polynomial. In Polynomial, we have discussed so many things in part first. Now the next, the value of the polynomial. Let Px is a polynomial and alpha is any real number. Now we want to find out the value of polynomial Px at alpha. Then put the value of alpha in place of x. Put the value of alpha in place of x. This will be value of P. You will get the P alpha. When you put the alpha in place of x, you will get the P alpha. That P alpha will be the value of Px. If P alpha is 0, then alpha is a 0 of the polynomial. When you put this value alpha in Px, either you will get 0 or you will not get 0. If you will get 0, then alpha is 0 of the polynomial, and if if P alpha is not 0, then it means that will be the value of the Px. Now, some important point about zeros, because we have discussed in second part that a linear equation, linear polynomial, quadratic polynomial, cubic polynomial, and bi-quadratic polynomial. So I want to discuss here that about zero, these polynomials, how much zero can have. A linear polynomial can have at most one zero. Here, I am giving you a very important point. Range of the zero. Range of the zeros. Very important point. First, a linear polynomial. A linear polynomial, I am writing polynomial in short. A linear polynomial can have at most, can have at most one zero. Can have at most one zero. Second, a quadratic polynomial. Quadratic polynomial A quadratic polynomial can have at most two zeros is equal to 20. Third, a cubic polynomial. A cubic polynomial can have at most three zeros. Fourth, a biquadratic polynomial. A biquadratic polynomial can have at most four Here, listen again. A linear polynomial can have at most one zero. A quadratic polynomial can have at most two zeros. A cubic polynomial can have at most three zeros. A biquadratic polynomial can have at most four zeros. According to this definition, if you find if you if you have to find out the zeros in any example, you have to see if the polynomial is linear, the zero must not be greater than 1. If polynomial is cubic, there must be 3 zeros. If biquadratic, there is 4 zeros. If quadratic, there is 2 zeros. So these are the condition. And if you take any example and find out 0, according to the condition is 0, 2, and you are getting 3, it means your answer is wrong. According to this condition, you have to check the zeros are according to these conditions. You are taking example whether the example is quadratic, whether the example is cubic, whether the example is biquadratic. After getting 0, compare with these norms. Again, a relation between very important topic. Now I am going to teach you a very important topic, that is relation between zeros and coefficients. Coefficients. My dear students, you can find out 0, and coefficients are given in the statement. Just I am repeating it again. For example, ax square plus bx plus c. You have to find out the 0. You will get 2 0, and the coefficients are a, b, and c. These are the coefficients given in the statement, and find out the zeros, and then find out the relation. Then what is the relation between zeros and the coefficient? This is a very important question. Now I am taking an example. Now one thing I want to tell you, a quadratic, this is a quadratic equation, ax square plus bx plus c. This is a quadratic polynomial, not equation. This is a quadratic polynomial, and it has two zeros. Let alpha and beta are the zeros. Then the relation between zeros and coefficients is alpha plus beta is equal to minus b upon a. Alpha beta is equal to c upon a. These are the zeros, these are the coefficient. This is the relation between alpha zeros and the coefficient of this quadratic polynomial. If you take cubic polynomial, ax cube plus bx square plus cx plus d. This is a cubic polynomial. And according to the statement that I have given to you, that cubic polynomial can have at most 3 zeros. Let alpha, beta, and gamma are the zeros. The relation between zeros and coefficient of this polynomial alpha plus beta plus gamma is equal to minus b upon a. Alpha beta plus beta gamma plus gamma alpha is equal to c upon a. Alpha beta gamma is equal to minus d upon a. This is the relation between zeros and the coefficient of this cubic polynomial. So I have given two examples, one of quadratic equation and second is the cubic quadratic equation, not equation, quadratic polynomial. And second is the cubic polynomial. So I am teaching you polynomials, not equation. Sometimes I may be wrong. So this is a cubic polynomial. Later on I will teach you equation also, but now I am taking polynomial. So this ax cube plus bx square plus bx is a cubic polynomial, and this is the relation between zeros and the coefficient. Now I am taking one example to make the concept clear. Whether I have given these statements or these formula, these are correct or not, because we should check. Now I am taking an example. One question. I am taking one question. X square minus 2x minus 8. This is example. X square minus 2x minus 8. This is a quadratic polynomial. And according to the condition, this quadratic polynomial can have two zeros, at most two zeros. Let the zeros are. Let the zeros are alpha and beta. Now first of all we have to find out the values of alpha beta. And how will you find out the values of alpha beta? First of all you have to factorize this polynomial. And in the first part you have seen how to factorize how to get the factors of a polynomial. First method was the splitting middle term. By splitting of the middle term, I am making the factor of this polynomial x square minus 2 and minus 4x plus 2x minus 8, because I have taken two constant 4 and 2. Multiplication of 4 and 2 is minus 8, and sum of 4 minus 4 and 2 minus 2. They see here, I have taken two constant minus 4 plus 2. Add these two, you will get minus 2. Multiply these two, you will get minus 8. These you have to check the condition here. Now making the pair x minus 4 and plus 2 x minus 4. Bracket should be the same, and take out the common x minus 4 and x plus 2. These are the two factors. These are the two factors of this polynomial px. This is the name of this polynomial. If Px is 0, Px is 0 when x minus 4 x plus 2 are zeros. It will be 0 if these factors are 0. Listen my point. Listen to me. X square minus 2x minus 8 is equal to 0. This will be 0 if these two factors are 0. When these two factors are 0, it means x minus 4 and x plus 2 is 0, or x minus 4 is 0 or x plus 2 is 0, or x is equal to 4 or x is equal to minus 2. This is the condition. X is equal to 4 and x is equal to minus 2. And these are the two zeros. Alpha is equal to 4 and beta is equal to minus 2. These are the two zeros. So the zeros of this polynomial, this is not an equation. This will be not proper to write equal to 0. Yeah, I have written for your understanding. So this is the condition. This is 0. Take it as. Now, don't think it is an equation. It is a polynomial, but for your understanding, this is I am making it equal to 0, because x minus 4 will be 0, then this will be 0. Either x plus 2 is 0, then this polynomial will be 0. And these are the two zeros. X square minus 2x minus 8. This is a polynomial, and 0 of this polynomial 4 and minus 2. These are the two zeros of this polynomial. Now take here a is equal to 1, b is equal to minus 2, and c is equal to minus 8, and alpha plus beta. Find these are the coefficient. Find out alpha plus beta. Alpha plus beta is equal to 4 plus minus 2 is equal to 4 minus 2 is equal to 2. Sum of the zeros is 2, and product of the 0 is equal to 4 into minus 2 is equal to minus 8. This is the product of the, this is the sum of the 0, and this is the product of the 0. Now I am taking first sum, alpha plus beta. Take it seriously. Alpha plus beta. Alpha plus beta is equal to 2. And it can be written as 2 plus 1, 2 upon 1. And here, what is the value of b? Minus 2. What is the value of b? Minus 2. And what is the value of a? 1. b upon a 1. But here 2 upon 1. Here minus 2 upon 1. We have to make it a 2. It means b upon a. Shift this minus to b. This is the condition. Minus b upon a. Alpha plus beta is equal to minus b upon a. You can see here. Second, alpha beta is equal to alpha beta. What is alpha beta? Minus 8, or minus 8 upon a. Minus 8 upon 1, and minus 8. What is minus 8? What is c? Minus 8. This is c. Or what is 1? A. A is 1. A is 1. C is minus 8. A is 1. Yeah. This is the condition. We have proved. Alpha beta is a product, and C upon is a coefficient division. And this is the relation between both are same. Alpha, beta and C upon A both are same. You can see. This is alpha plus beta and this is C upon A. One and the same thing. This is alpha plus, this is alpha beta, this is alpha plus beta, and this is minus B upon A. This is minus B upon A. This is alpha plus beta. Both are same. Hence, this relation is proved. For a quadratic polynomial, alpha plus beta is equal to minus B upon A and alpha beta is equal to C upon A. These are two relations between zeros and the coefficient of a quadratic polynomial. In the same way, you can find out the relation between a cubic polynomial in which there are three zeros, alpha, beta, gamma, and that relation can be proved in cubic polynomial also. This is a very important topic. First of all, when quadratic polynomial is given, first of all find out the factor of the polynomial, then find out the zero of the polynomial, then write down the coefficient of that polynomial a, b, c, and then compare alpha plus beta with the coefficient and alpha beta with also with the coefficient, and check whether alpha plus beta is equal to minus b beta a or alpha beta is equal to c upon a. If this condition satisfied, then our assumption, our formulas given are correct according to the definition. So this is the checking of the sum and product of the zeros of a quadratic equation. So my dear students, this was the second part of the 10th class mathematics, second chapter polynomial, and I will take third part of this polynomial chapter later on. And in the last, I want to make a request to you. Please subscribe the channel. I shall be very thankful to you. Thank you.